So we've got this skater, and he's at the top of a ramp. And we're going to say the ramp is 15 meters up, and he's got a mass of 45 kilograms. He's on the planet Earth, so gravitational field strength is 9.81. And what we want to know, really, what we're trying to do is identify what is his final speed going to be as he gets to the bottom there. So that's the question. He's 50 meters up. His mass is 45 kilograms. He's on the planet Earth. And we want to know, what is his final speed going to be? So I've said here at the beginning that u is 0, v is, well, question mark, we don't know. And what we're going to do is we're trying to work out what v is. So the first thing we need to consider is the fact that gravitational energy is being converted into the kinetic energy. And in our scenario, in our simulation, there is no friction, and we're going to say no air resistance either. So normally it would also make some thermal energy, but what we're going to say is it doesn't make any thermal energy. So normally gravitational energy would be equal to the total gravitational energy, the total energy put in would be equal to the kinetic energy plus the thermal energy, but we're going to ignore the thermal energy, so it's just going to be equal to the kinetic energy. So we can work out the gravitational energy. So yeah, basically we're saying then that the gravitational energy turned into the kinetic energy, and so we're going to calculate the gravitational energy, and it's equal to 45, which was its mass, m, times gravity, which is 9.8, gravitational field strength, times 15, and which was the height. So which comes out as 6,615 joules. Now that is going to be also what his kinetic energy will be. So his kinetic energy is going to be that. Now we know that's what the kinetic energy is going to be, but we don't know what that velocity will be. So we can use that to rearrange. We can rearrange the formula, which isn't straightforward, to be honest with you, but we can rearrange this formula, which is half times the mass times the velocity squared. We can rearrange that formula because now we know the mass and we know the kinetic energy. So we've got one unknown in the equation, so we can rearrange it. But it's not straightforward, but give that a go. Okay, so let's have a look what the student's done then. So they first of all divided by half m, and that moves that over there. So E kinetic energy divided by half m is equal to v squared, and then they've square rooted both sides. So yeah, that would work fine. There is a way of making it a little bit tidier, and that is using the general sort of algebraic rule, which I'll write in pink over here, that A divided by B over C is identical to A multiplied by C over B. So when you divide by a fraction, it's the same as multiplying it by the upside down fraction. You could then also rewrite that as C over AB. Now that means that when you get to this stage here, kinetic energy divided by half m, well, when you divided it by the half, that's identical to 2 at the point 2 at the top instead of half at the bottom. And so 2 times the kinetic energy divided by m. And so generally how you would see it written in textbooks would be in that format. So square root of 2 times the kinetic energy divided by m. Okay.